Okay, scholars, we're still in chapter 4, lesson 4, and I'm going to show you a different way to factor because now that we're into polynomials, we're moving beyond trinomials. And so with the higher powers, and sometimes as you can see different variables, you can do this method on 4-term polynomials. So basically what you're going to do is, I mean, normally you'd look for a greatest common factor, but I have a 3 and a 4 and a 6 and 8, and they don't all have something common. But what you can do is just like take 2 of them and see what those 2 have in common, and maybe 2 other ones and see what they have in common. And you get lucky very often. So here's again, you can write down these examples. Pause this for a second so you can write it down. But when I look at these, I think, well, those have an x squared in common, if I just look in order, right? But these, well, all they have is a 2 in common. So that would work. But let's see, I also, if I wanted to, I could group these 2 here because they both have a 3 and an x in common. And these 2 here have a 4 in common. So really, you can do it a number of different ways. You'll end up with the same. Let's just jump right in. I'm going to go ahead and do these 2 together because they're in order. And then I'll do these 2 together. And it'll all end up the same no matter how you do it. But if I look for the greatest common factor of these 2 terms, it's just x squared. So I'm going to write an x squared here. Okay. And if I take an x squared out of this term, or in other words, this times this equals 3x cubed, then I get a 3x. X squared times 3x equals that. So those 2 are factored. And then if I take an x squared out of this one, it's going to be a minus 4 because minus 4 times x squared gives me that. So I hope this works, right? That's what we're doing. We're just taking a look. If I look at these 2, the only thing in common really is a 2. So what I'm going to do is I'm going to take a 2 out of these 2 terms and see what happens. If I take a 2 out of a 6x, I'm left with 3x. If I take a 2 out of a minus 8, I've got a minus 4. And oh, look at this. Hopefully you can see right here that I have 3x minus 4 and 3x minus 4. That is a common term. So both the x squared and the 2 is multiplying it. And so since it's common, what you can do is you can take this and write them together, okay, like this, x squared plus 2, and they are both multiplying this common factor of 3x minus 4. And that is the beauty of grouping by factoring. Had you reordered, like I mentioned with the other way, you would have gotten the same thing. But now I have 2 binomials, and that's going to be a lot easier to solve when we move on to solving. Okay? Hopefully everybody's following right along with this. So for this next example, I have 3a squared minus 2ab minus 6a plus ab. Now, when I look at these first 2 in order, they have nothing in common at all. So I'm going to have to rewrite this, okay? In other words, what else could I group the 3a squared with? Well, I could group it with 6a or ab because they both have an a in common. But this 2b, the only thing that's gonna, well, I could group that with this because they each have a 2 in them, or the b's, I could put the b's together. So I think that's what I'll do. I'm just going to rewrite it so that the 6a is with this and the 2b is with this. It's a little easier to see this way, I hope. And so these first 2 have a 3a in common. That is going to be their greatest common factor. And then these 2 simply have a b in common. So we'll just do one thing at a time, but I just want to notice that. So they have a 3a in common. So I'm going to take a 3a out of this term, which means 3a times this gives me 3a squared. That'll be an a. And 3a times minus 6a will be a minus 2. For the next two terms, I have b's in common. Now, because I have a minus here, I'm going to take out a negative b, just for that one reason. So negative b out of both terms. So negative b times what will give me negative 2b? That's going to be a 2. And then if I take out a negative b from plus ab, like what times this will give me AB, so that's going to be minus A. Now, the funny thing about this is A minus 2 and 2 minus A are super close, okay? But if I had rewritten it, okay, these could be switched. So if I take out a negative 1 here, I'm still going to be able to get my plus B. So this, I'm going to rewrite it like this. Nope, that's not what I meant to do. I wanted to rewrite it like this, AB minus 2B. So if I look at it a little bit of a different way, okay, and I see that the common term is B, okay, so here's my first terms, here's my second one, then this is going to be B, A minus 2. So sometimes you have to play with it a little bit so you can see that you'll get the common factor. And here is our common factor. It's A minus 2 here and A minus 2 here. Hopefully you can see that. And the common things that are multiplying it are 3A, so that's going to come down here, and a plus B. And that's going to come all the way over here. So I get 3A plus B, and they are both multiplied times A minus 2. It's a little bit of a just sort of jiggling it around to see how it'll work. That's why we're going to practice a bunch of these in class. But now, instead of not being able to factor that, I have two solid binomials. Okay, we're going to move on to just A's and D's. And again, I've got these things in order, so I think I'll go ahead and just do the first two and the second two. Okay, so these two, I'm looking at them, they have an A in common. And these second two, well, they both look like they have a negative D. So I'm going to do this negative D. And then I can go ahead and take these out. So A times what equals AD? That's going to be a D. A times what equals plus 3A? So that's going to be plus 3. Now, whenever you have a minus, you have to be careful here. What times minus D will give me minus D squared? That's going to be a D. What times negative D will give me minus 3D? That's going to be plus 3. Yay! So again, I notice here I have a common factor. I have D plus 3. These are both multiplied times D plus 3. So I take what they're multiplying, which is A and a minus D. And those I'm going to rewrite together as a common factor, A and minus D. And they are both multiplying D plus 3. There you go. That is your final answer, because I can't factor it anymore, and now I have two binomials, which is what I want. I'm going to keep plowing along. I know that it's not always easy to follow, but every once in a while you'll get a problem that it looks like you should be able to factor it, but you can't. Okay, and it all depends on the pluses, the minuses. Sometimes you end up with something called prime. So we're going to do it both ways here. I'm going to do it just the way it is with these two and these two, and then I'm going to try to rearrange it. This is an example of where I won't be able to. So you've got to see what it looks like when it's prime also. So these two have an n squared in common. You can go like that. And these two have a 3 in common, and that looks like about it. So I'm going to do plus 3 here. While I have my blue pen, 3 times what is 9n, so that's going to be a 3n. 3 times what is negative 12, that's a minus 4. And then I'll go back to the green here. n squared times what is 3n to the fourth? That's going to be 3n squared. And then n squared times what is minus 4n squared? That's going to be minus 4. Well, I'm looking at these two common factors. This is a 3n squared minus 4, and this is a 3n minus 4. So because of that n squared, they're not exactly the same. And this just doesn't work. This would be a big, like, boo, big red X. Okay. So instead, what I'm going to do is I'm going to try it again, but I'm going to reorganize. So what else could I do? I know my 3n to the fourth, I could probably group it with the 9. I could also group it with the 12. But then I look at this, my 4n squared. Well, I could group those two together with an n, or I could group those two together with a 4. So I think what I'll do is I'll just swap these and see what happens. 3n to the fourth plus 9n minus 4n squared minus 12, and I'll try it that way. Okay, and let's see if we have any better luck. So these two have in common a 3 for the coefficients and an n. And then the ones next to it, these here, they're going to have just in common a minus 4. That's what it looks like. So I'm going to try to take these out, get my greatest common factor. 3n times what is 3n to the fourth? So that's going to be n to the third plus 3, because 3n times 3 will give me 9n. And then this one, 4 times n squared will give me 4n squared. And then plus 3 minus 4 times plus 3 will give me minus 12. So again, I look at this and I've got these multiplying these, but that n cubed and that n squared messes the whole thing up. They're close, but they're not exactly right. So I could try to reorganize it one more time, or just recognize that this one is not going to work. The first three did, this one doesn't. And we call that situation prime. So sometimes that does happen. Not always. That's called factoring by grouping. Again, we'll practice it in class.